Students, let us continue to discuss another method in module 4, numerical solutions of ordinary differential equations. So in the previous classes we had seen 4 different methods which can be used to solve first order first degree differential equations. So here, which are all the methods that we have already seen are Taylor series method, modified Euler's method, Milne's method, Runge-Kutta method. And continue to do, there's another method which is also very important to solve the first order first degree differential equations. So which is that method is? The method is ADAMS-BASHFORTH predictor corrector method. So which is ADAMS-BASHFORTH predictor and corrector method. Even though the concept is same, like Milne's is also having predictor and corrector formulas to evaluate the value. Similarly, ADAMS-BASHFORTH also is having a value, having the one particular function. Then how exactly this Milne's and ADAMS-BASHFORTH are different? So looking at the formula only, we need to find out the difference between Milne's and ADAMS-BASHFORTH. So here, consider a differential equation as usual, a first order first degree differential equation with the initial conditions. The initial conditions are y of x0 is equal to y0, y of x1 is equal to y1, y of x2 is equal to y2, and y of x3 is equal to y3. So here, there is a slight difference has been given. So usually the different authors will define in different ways. So if you start the values from x0, x1, x2, x3, and the corresponding values will be y0, y1, y2, y3. But instead of starting from x0, x1, x2, what we have done is we have started from x minus 3, x minus 2, x minus 1, and then x0. So these are the values have been given. The corresponding values like y minus 3, y minus 2, y minus 1, and y 0. And we need to evaluate the value of y1 if we take this set of values. If we consider this set of values, then it will be, you have to find y4. So different authors are used different notations. So since I want you to be clear with all the ways, and based on your convenient, you can use a suitable ways to remember the formula in your own way. So hope you understood this. So already I had used the set of values as x0, x1, x2, x3, and the corresponding value is y0, y1, y2, y3. So now let us make an attempt to use in a different way so that it will be easy for us to understand all the ways, all the methods. So here let us continue to take y minus 3. Y minus 3 is y minus 3 is equal to y of minus 3, and y of minus 2 is y minus 2, y of minus 1 is y minus 1, and y of x0 is y0. So let us take this, and according to this we will be evaluating y1. So y1 predictor formula is y0 plus h by 24, y0 plus h by 24, so let us evaluate y1. y1 at p is equal to y0 plus h by 24, 55 y0 dash minus 59 y minus 1 dash, 37 y minus 2 dash, and minus 9 y3 dash. Similarly, the corrective formula is given by y0 dash So let us continue to evaluate y1 at p and y1 at c. So if at all you take the values, as I said, if you start from x0 here, that is y0, then x1 y1, x2 y2, x3 y3, then you will have y4 here. Accordingly, you have to change. This will become your y3 plus h by 24, 55, y0 dash. y0 dash will be your y3 dash minus 59 y minus 1 is nothing but y2, and then this will be y1, and this will be y0. So that is the formula. So accordingly you will be changing, as I have already written and show you. If you start from x0, y0, x1, y1, x2, y2, x3, y3, the formula is going to be changed. So this is another way of representing it. So I am introducing both the ways for you. Whichever is convenient for you, you can use it. And corrector formula has been given by this. So now let us see some examples so that you can understand the concepts in a better way. So use ADAMS-BASHFORTH method to find y when x is equal to 1.4, given that dy by dx is equal to x square into 1 plus y. Y of 1 is 1, y of 1.1 is 1.233, y of 1.2 is 1.548, y of 1.3 is 1.979, and apply the corrector formula twice. Since it is specified, we have to do it. So as usual, mark a table which fulfills all our requirement. Set of values of x which are given by this, set of values of y which have been given by this, and observe this is what is the representation I am using it. Okay, and y dash is nothing but other than the first order derivative, whatever you have will be your y dash, which is x square into 1 plus y. We need to evaluate them. Y minus 3 dash is nothing but y dash at x minus 3 and y minus 3, which is 2. Similarly, y minus 2 dash is y dash at x minus 2 and y minus 2, which is 2.702. And y minus 1 dash is nothing but x minus 1 at y minus 1. The answer is 3.669. And y naught dash is at x naught and y naught, which is 5.035. And the value of h is 0.1 and x1 is 1.4, where we need to find our y1. So y1 will be found by using the predictor formula. The predictor formula is given by y0 plus h by 24, 55 y0 dash minus 59 y minus 1 dash plus 37 y minus 2 dash minus 9 y minus 3 dash. Substituting and simplifying, we get y1 at p as 2.573. And y1 dash need to be evaluated because we want this value to be used in corrector formula. So y1 dash is y dash at x1 and y1. So y1 value we have evaluated, use that, and the value is going to be 7.004. And now apply the corrector formula. This is the corrector formula. Substitute all the values and simplify, you get 2.575 the corrected value. So since it is asked us to apply the corrector formula twice, so this y1 dash need to be evaluated again by using the very recent value of y1. So which is again 7.007. And substituting the values in the corrector formula again, will get y of 1.4 as 2.575. So look at another example. The dy by dx has been given as half xy, and find the value of y at x is equal to 0.4 using ADAMS-BASHFORTH method. This is the values have been given. And tabulate the values of x and y which is given. Y dash value need to be evaluated. Y dash expression is xy by 2, and evaluate y minus 3, y minus 2 dash, y minus 1 dash and y naught dash, and tabulate it. So once after tabulating it, as usual, write down the predictor formula, make a substitution and simplify. We get the answer as 1.0408. Evaluate y1 dash, x1, y1 by 2, and the answer is going to be 0.2082. And using the corrector formula, this is a corrector formula, make a substitution and simplifying, y of 0.4 is 1.0408. And it is asked us to apply the corrector formula twice, so you need to evaluate and substitute it again. So look at another example. So here dy by dx is x square minus y. Y of 0 is 1, y of 0.1 is this, y of 0.2 is this, y of 0.3 is this, and x is equal to 0.4. X values, y values and y dash values need to be evaluated and tabulated. H is 0.1 and x1 is 0.4, where we need to find the value of y1. So y1, by using the predictor formula, write the formula and make a substitution and simplify, evaluate the value which is 0.6897. Evaluate y1 dash because it is required in our corrector formula. The answer is minus 0.5297. Substitute these values in the corrector formula and you get the value of y of 0.4 as 0.6897. So this is how we need to evaluate the problems on ADAMS-BASHFORTH. So as I told you, more and more problems if you solve, you will be getting a confidence in solving any kind of problems. So maybe the variables may change. So whatever the problems that we have done here is having y and x as the variable. Maybe you may have x and t, y and t, theta and t, anything. So whatever the variables have been used, formula also must be changed accordingly. So this is about your ADAMS-BASHFORTH predictor and corrector method. So thank you.